Welcome to 3 Inquisitive Kids. This video will be about using the scientific notation to write smaller numbers. Here's our course outline. We are on our 5th lesson of Unit 7, and after learning about the laws of exponents, we're going to be learning about using the scientific notation. The scientific notation is a way to write numbers in decimal form using the powers of tens. Learning goals. Using the scientific notation to express smaller numbers with absolute values less than 1. Using the scientific notation to solve word problems. Review. What is the scientific notation? The scientific notation is a way we express very big or very small numbers. It turns a number into decimal form, which makes them easier to calculate. Numbers with absolute values is greater than 10, recorded in the form of a times 10 to the nth power. A is greater or equal to 1 and less than 10. And n is a positive integer. But in this lesson, we're going to be learning how to use a scientific notation to rewrite smaller numbers. For example, 864,000 can be rewritten as 8.4 times 10 to the 5th power. Remember, you have to leave only one digit in the ones place over here before the decimal point, and then times 10 to the blah 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 power. Here we can see that it was 10 to the 5th power because 1, 2, 3, 4, 5. But how would you express 0.0000864 using the scientific notation? Now we're not getting bigger numbers, we're getting smaller numbers. So how would you write that using the scientific notation? Using the scientific notation to rewrite smaller numbers. We know that 0.1 is equal to 1/10, which is also equal to 10 to the negative 1 power. 0.01 is equal to 1/100th, which is also equal to 10 to the negative 2nd power. 0.001 is 1,000th, and it is equal to 10 to the negative 3rd power. So how would you rewrite 0.0000864? Well, basically, 0.0000864 is equal to 8.64 times 0.00001, and this 0.001 is the same as 10 to the negative 5th power. So we end up with 8.64 times 10 to the negative 5th power. Remember, now we're using negative exponents. For numbers with absolute values smaller than 10, we can use negative exponents with the scientific notation. A times 10 to the negative nth power. N is a positive integer and 1, and the absolute value of A is greater or equal to 1, but less than 10. Now I want you to calculate the following: 10 to the negative 2nd power, 10 to the negative 4th power, and 10 to the negative 8th power. So 10 to the negative 2nd power is 0.01. 10 to the negative 4th power is 0.0001. And 10 to the negative 8th power, 0.00000001. That was a lot of zeros. What is the relationship between the exponent and the number of zeros in the result? Over here we can see that we have a negative 2. And we have 2 zeros in the result. For 10 to the negative 4th power, we have 1, 2, 3, 4 zeros. The negative 8th power, 1, 2, 3, 4, 5, 6, 7, 8 zeros. Generally, in 10 to the negative nth power, there are n zeros. So if I had 10 to the negative 5th power, there would be 5 zeros, including the one before the decimal place. And if I had 10 to the negative 1,000th power, there would be 1,000 zeros. knowledge point. Using the scientific notation to express numbers with absolute values less than 1. Over here we have 0.0003, which equals 3 times 10 to the negative 4th power. We can see that there are 4 zeros, and the exponent is a negative 4. Example 1. Use decimals to rewrite the following expressions. Pause the video and do this by yourself first. Well, this should be easy. This is just moving the decimal point. So for the first problem, we have 2 times 10 to the negative 7th power. So we get 0.000, like 7 zeros in total, and then a 2. For the second problem, we have 5 zeros in total, and then 3, 1, 4. 0.00708, and then 0.217. Practice. 1. Rewrite the following in scientific notation. So now we're going to be converting decimals into the scientific notation. For the first problem, we have 3 times 10 to the negative 5th power. 1, 2, 3, 4, 5. So that's why we have a negative 5 as an exponent. And then over here, we have actually a negative number because we can see that there is a negative sign in front of the absolute value. 1, 2, 3, 4, 5, 6. We're going to stop right here because we always leave one digit in the ones place. So we get negative 6.4 times 10 to the negative 6th power. And for the third problem, we get 0.14 times 10 to the negative 5th power. Summary. With the negative multiples of 10 as our exponents, we can write down numbers with some really small absolute values. A times 10 to the negative nth power, where n is a positive integer. The absolute value of a is greater or equal to 1, but smaller than 10.